Hello and welcome to our lesson on transforming graphs. Today, we will explore some powerful techniques that will help you understand and manipulate the graphs of functions, which is crucial for various algebraic and real-world applications. In this lesson, we'll focus on transforming a graph using specific function modifications. Our primary goals today include 1. Understanding how to shift a graph vertically using f of x plus a. 2. Learning how to move a graph horizontally using f of x minus a. 3. Discovering the effects of reflecting a graph across the y-axis with f of minus x. After explaining these transformations, we'll apply this knowledge to a series of examples to reinforce your understanding and illustrate practical uses. So far, we've established a solid foundation in basic graphing concepts by covering plotting linear equations, understanding the Cartesian coordinate system, identifying and interpreting key features of graphs such as slope and intercepts. With this foundational knowledge, we're now ready to delve deeper into graph transformations. This technique is essential for efficiently analyzing and manipulating functions. Imagine you're given the function f of x representing a company's revenue over time, and you need to predict how changes in market conditions could shift this graph. Using transformations like f of x plus a and f of x minus a allows you to model potential outcomes and make informed decisions. Let's get started. Let's go step by step to understand how to transform graphs using specific function modifications. First, let's understand how to move a graph up or down. When we add a constant a to a function f of x, it shifts the graph vertically. Begin with the most basic graph, y equals x. If we have y equals x plus 1, this moves the graph of y equals x up by 1 unit. Each point on the line y equals x is lifted 1 unit higher. If we have y equals x minus 1, it moves the graph down by 1 unit. For any linear function y equals x plus a, the graph is moved vertically by a units. If a is positive, it moves up. If a is negative, it moves down. This concept is not limited to y equals x. For example, if we take y equals x squared, the transformation y equals x squared plus 2 will shift the parabola up by 2 units. We can describe the movement of any function af of x by adding a to it. Thus, f of x plus a translates the graph vertically by 0a. This formalizes our graphical shifts. Next, we learn how to move a graph left or right. When we adjust the input of the function by subtracting a, it shifts the graph horizontally. Consider y equals x squared. Compare y equals x squared with y equals x plus 1 all squared. This graph moves to the left by 1 unit. Alternatively, y equals x minus 1 all squared would move 1 unit to the right. For any function f of x, transforming it to f of x minus a shifts the graph horizontally by a units. If a is positive, it moves to the right. If a is negative, it moves to the left. Notice that transforming the function to f of x minus a means a is inside the bracket. This change translates the graph by a 0. Finally, let's explore how to reflect a graph. To reflect a graph about the y-axis, we alter the input to be negative. Start with y equals x squared. Reflecting it by using y equals minus x squared results in the same graph, since minus x squared equals x squared. For a linear function like y equals 2x plus 3, we get y equals 2 times minus x plus 3 or y equals minus 2x plus 3. And we reflect the graph across the y-axis. Positive slopes become negative and vice versa. Transforming a function to af of minus x reflects the graph over the y-axis. This is because negating the input changes the sign of the x-coordinates, flipping the graph horizontally. To reflect a graph about the x-axis, we alter the output to be negative. For example, start with y equals x squared. Reflecting it by using y equals minus x squared flips the graph upside down about the x-axis. For a linear function like y equals 2x plus 3, we get y equals minus 2x minus 3, and we reflect the graph across the x-axis. Positive y values become negative and vice versa. Transforming a function to minus f of x reflects the graph over the x-axis. This changes the signs of the y-coordinates, flipping the graph vertically. These transformations help us visualize how adjustments to a function's equation affect its graph. Understanding these fundamental transformations will allow us to more effectively analyze and manipulate functions in algebra and real-world scenarios. Let's dive into some examples to illustrate how to transform graphs using the methods we've discussed. Example 1. Vertical shift. Start with the function f of x equals x squared, which is a standard parabola. Now let's apply a vertical shift by adding 2 to the function. F of x plus 2 equals x squared plus 2. This transformation shifts the entire graph up by 2 units. In the diagram, you'll see that every point on the original parabola has moved upwards by 2 units. Example 2. Horizontal shift. If the original function is f of x equals x squared, what is the new function after a horizontal shift of 4 units to the left? The new function will be f of x plus 4 squared. This shifts the graph 4 units to the left. Example 3. Reflection across the y-axis. Reflect the function f of x equals x cubed across the y-axis. The new function will be f of minus x equals minus x cubed. This transformation flips the graph horizontally over the y-axis. Example 4. Combined transformations. Let's combine these transformations. Suppose we start with f of x equals x squared, and we want to shift it 3 units up and 2 units to the right. First, apply the horizontal shift. F of x minus 2 equals x minus 2 squared. Next, apply the vertical shift. F of x minus 2 plus 3 equals x minus 2 squared plus 3. By understanding these transformations, you're now equipped to tackle a variety of graph manipulation problems. Use the diagrams to visualize these changes and practice applying these steps to different functions. Extension knowledge. Transformations on graphs, such as translations and reflections, are used in computer graphics to create animations and visual effects in movies and video games. These mathematical techniques allow designers to move, rotate, and scale objects seamlessly, bringing characters and scenes to life. Without these transformations, the stunning visuals and dynamic animations we see in our favorite films and games wouldn't be possible. In today's lesson, we explored the concept of graph transformations, focusing on 3 primary modifications: vertical shifts, horizontal shifts, and reflections. We began by understanding how adding a constant to a function, f of x plus a, shifts the graph vertically. If the constant is positive, the graph moves up, and if negative, it moves down. Next, we examined horizontal shifts using f of x minus a, where the graph moves right if a is positive and left if a is negative. Lastly, we discussed reflections starting with f of minus x, which reflects the graph across the y-axis, and minus f of x, which reflects it across the x-axis. These transformations provide a powerful toolkit for visualizing and analyzing the effects of changes to a function's equation, helping us in both algebraic contexts and real-world applications. Understanding these transformations enhances our ability to manipulate and predict the behavior of various functions efficiently. Watch the rest of the GCSE Maths course at Sophos Education.